and welcome to Go Templates, Great Library, Bad Rap. My name is Carson Anderson. I'm a DevX engineer at Weave. What that means is that at Weave, I don't necessarily build the product, although sometimes I do. Me and my team are responsible for building the tooling and the systems that our engineers at Weave use to deploy what they're building and to deploy the product. We're responsible for making their lives easier. Part of that is that we've built a massive high-scale deployment system for all of our engineers at Weave. And at the very end of that deployment system, we make great use of Go templates. It allows us to, on the fly, kind of tweak and modify how things are deployed, and to kind of expose some of the logic behind the system to our engineers without requiring them to understand too much about the rest of it. Like you might guess from the title, I really think that Go templates as a package gets a bad reputation. I don't know why, maybe it's just stuff that I've heard over time. There are a few things about the library that can trip you up if you're not aware that it's going to happen. So as we go throughout the rest of the presentation, I'm going to talk about things that I think trip people up and kind of maybe are part of that bad reputation. But I'm also going to talk about what I love about the language and show you some power user moves to really take advantage of the language and make it work for you. So let's go ahead and dig right into Go templates. So first question may seem kind of obvious, but I really want to cover it, and that is, why do we need templates at all in any language? What is the whole point of dealing, like, why would I want to go outside of standard Go, or whatever my language is, and write a new language? Primarily, we want to avoid something like this. Now, this isn't a terribly complicated bit of code. I've got an inline struct where I'm defining some fields, and I'm immediately creating that struct with that data. This is a nice, clean way to showcase the data that I'm going to feed to templates as we go, so you'll see this a lot. The actual code here, though, isn't using templates. It's just using prints. So we're printing company, the company name. We're saying, hey, if there's some employees, print those employees. And then for each of them, loop through and print a hyphen and the employee. This isn't a terribly complicated bit of code. But even already, you can see that we've hard locked in our presentation logic with our actual code. And what we've got here on the left isn't really representative of the output that we got. Let's complicate this a bit further. I'm going to add a teams map. This is a map of team name to the members. And it's, again, not that much more data, but if I want to use this in my output, look what it looks like. This has now gotten way more complicated. It's almost impossible to read. It's essentially the same code up to here, but I've added this new section. And if you pay attention, I've even put in a helper function where you say employee teams, give it the name of employee, and it will return the teams that an employee is a part of. So even with some helpers to do kind of some extra double loop logic, this isn't super easy to read, and it's definitely not representative at all of the final output of this program. So we don't want to do this. We want to fix this. And one way we can fix this, to nobody's surprise, is by using templates. Now don't worry if anything you see here you don't recognize. I'm going to cover every single piece of templates, how you use them, all the pieces of language I'm showcasing here. What I want you to look at this point in time is how much more representative this top section of template code is with our output. It's not perfect, but it's a lot better than the previous prints. Even better, now that we've ripped it out of our code, we could swap it. The code here at the bottom is unchanged, but notice now I can say, well, that's the verbose company report. Here's a different template to take that same data, render it in a clean, simpler report. And I could use both or either, or I could swap depending on user input. By swapping these out, I really allow my display logic to be separate and compartmentalized. So that's why we want templates in any language, is so we can separate our presentation logic from our code. And as a bonus, you can make that presentation logic user definable. So the user might be your end user. You might actually get that from a file or a web call or a database. You can kind of get that template code from anywhere without having to recompile your code. So it makes it really modular. So that's enough about why. Hopefully you understand now why we even bother with a second language in the first place. Let's talk about how we use the template language. Lucky for us, Go has a really powerful standard library. And what that means is that we don't have to go out to get a different template package. We can just use the built-in ones, and there are two. They function nearly identically, but there are two of them. There's the text template package and the HTML template package. I will say be wary. If you just type template dot and any of the functions we're going to cover here in a second, and your editor is set up to auto import packages, go double check that you got the one that you want It's probably text template, but it might be HTML. And if you don't know what the difference is, I will show you in a second. But like I said, they're almost 100% identical between the two. So basic usage of the Go template package is like this. You say template.new, give it a name, and now we've got a template variable that's empty. Of course, an empty template variable isn't very useful, so what we want to do is parse our template text into that to make it usable. So we take that template variable that we got and we call .parse on it, and we give it some template text. In this case, a raw inline string, hello from, and this placeholder. I will cover these in detail, but understand right now, whatever we give the template, this is just the default placeholder. Interestingly enough, we get the template that we already had back from .parse. I'll explain why in a second, but it's kind of interesting. We have it, and then we get it back again from the function call. But once we've got that, no matter how we got to that parsed template form, we can then execute that template, tell it where to write the results. In this case, I'm just writing to standard out, but you could write it to a buffer, you could write it to anything. It's a standard writer interface, so any way that you could write anything. Then we give it some data. Now, this second argument is an empty interface, so it can take anything. But in this case, I'm keeping it very simple and just giving it a single string as the data. There are a couple errors here that I'm handling, but I've made a note that they're really not reachable in these examples. So that's it. That's a very, very basic usage of the template package. I was saying hello from, and then this whole last section was Go templates with an exclamation mark. Now this is the long form, simplest form of this, but I don't like long form. I like quick and easy. So let's compact this just a little bit. We can kind of take those two first calls, take the template.new, and immediately call .parse, because an empty template is almost useless. And this is why .parse returns something you might already have, because really this is kind of the standard canonical invocation of this. There are actually a few parse methods that come off template. You can parse files or file systems. I'm not going to show you those, but because there's a few ways to fill a template with data, you kind of almost never see template.new on its own. But then I go ahead and execute that again to standard out, and we see the same output that we got before, but with a lot less code. Ignoring these errors is fine for now because we know that this isn't going to fail, but I kind of still want to check those and maybe panic. And lucky for us, the template package comes with a helper. It's called template.must, and it allows us to handle the two output variables from the end of this .new.parse. And following Go convention, if that second argument, which is an error, that second return is an error, and the error is not nil, it will panic. So you have to do this or just panic the program. This allows us to sort of handle, as soon as we run the program, it's going to panic if the data, in this case it's static, isn't valid for the parse. So then we get that template, and then we can do the execute like normal. And so this is kind of the safer way to condense it without having to write a lot of code, but still catch errors. So this is the thing I'm going to use throughout the rest of the presentation. When I do show it to you, you're going to pretty much always see it wrapped in a .must. Although you could just get the error and handle it like normal. So I promised I'd tell you the difference between text versus HTML template, and here's my example for it. Like I said, they're almost 100% identical in the way that you use them. They just have slightly different output. So if you accidentally import the wrong one, it's going to behave pretty much how you expected it, except for one big use case. And I'm going to illustrate that here. I'm making an HTML template by using the HTML alias for HTML/template, and the same thing for text template. It's identical template text, two variables. I'm then going to execute them with near identical input data, and we're going to see the main difference between those two packages. And so if you look carefully, you see really the big difference between HTML and text template is that HTML template, anything that you render out as a result of the template that's a placeholder, will get HTML escaped by default. Now there are ways to do HTML escaping in text template, but by default everything in HTML template is escaped. And that's why I say, if you accidentally pull in the wrong one, it'll probably work just fine for you for a long time until something really weird happens and you get a bunch of HTML escapes that you didn't expect. So be aware that the two exist. I'm going to use text template for the rest of the talk. So we've been using these raw strings, and that's fine for one line or very, very small. In this case, this is just a 3-line template execution. And that's not too bad, but I want to show you what we can do to kind of fix this. Because as these get longer and longer, it's really not an ideal way to edit template text. We could rip it out to a constant, of course, and that does make it a little cleaner, because at least that constant's at the top and separate from our parsing. And that works, but it's still not ideal. I could put that into a file and I could read that file at runtime and then parse at runtime, and that's pretty good. In fact, this might be exactly what you want if you want your templates to be user definable and to change, and you want them to be dynamic. Large dynamic templates, reading from a file is probably a great way to do it. But I want to talk about what happens when I have large static templates. And for that, we're going to need the new version of Go. In the newer versions of Go 1.16 plus, you can now use Go embed. So I won't go over in detail how to use Go embed, but effectively we import embed for effect. We create a variable of a couple different types, and we do this special comment at the top that says, hey, I want you at compile time to find the file located in this directory at this path and embed its contents into this variable. So when I compile, the compiler is going to parse that, and it'll error if this doesn't exist, but it's going to essentially load a variable for us. We can then parse it like normal, and if I run this, you can see that, yep, the contents from hello.temple got loaded into that variable. And the cool part about this is, if I don't want to ship these template files to my users, if I want just big static separate template files for easy code control and readability and syntax highlighting, I can put them in dedicated files and use Go embed to just kind of seamlessly pull them into my program and build them into my binary and just ship one thing to my users. So that's a nice little trick that was only recently made possible with default Go. That's enough about how we run it. There are a few more things and kind of special use cases like I mentioned, but that's the bulk of running templates. What I want to spend the rest of our time on is talking about the template language itself and the nuances around that. So let's first talk about simple pipelines. What I want to say real quick is that you're going to see basically a lot of slides like this from now on. I'm going to show you the data that I'm going to give to the template and then the template itself. Unless it's meaningful, new, or different, I'm not going to show you the Go code because you can assume it's the standard parse and execute code that I just showed you. In some cases it's different, and I will show that to you, but if you see pages like this, just know that behind the scenes I'm parsing this and feeding it this data. So here's something that we've been doing a lot in the template so far, and that is what you might call interpolation or printing. In the Go docs, they call these pipelines. And this is important, and I'll explain why they're called that in a second. But you can think of them sort of as replaces. Now, we use, in all Go template functions, we use a double curly brace by default. You can change that, but by default, a double curly brace to start and end a bit of template logic. And in this case, we're just saying, hey, I want you to take all of the data that you've given me and just render it out. I can also index things. So I can say, hey, I know the data that you're going to give me has this company field, so I want to get .company or .employees. Now, if I run this, you'll see that I don't have to just give it strings. I can give it basically anything to render to the template. And if this output looks familiar, I can show you why. If I take this away and I just do a bunch of prints, where I print data and then give it data, print company, give it company, and I run this, you'll see that, yep, pipelines in Go templates, when you render them out, use the same stringer interfaces that all of fump.print whatevers do. So if you're curious how something's going to render in your template when you put it in a pipeline, just think of how print's going to handle it, including, like I said, stringer functions. But why do we call them pipelines? So far we've seen this very, very simple, just render one thing out. And that works just fine. And you can see here we go, I'm rendering that out. But we can do a lot more with pipelines in Go templates. We can call functions. In this case, I'm calling the built-in HTML function, giving it all the data. And you can see that this is how I would manually HTML escape if I didn't want to use HTML template. If I only wanted to occasionally HTML escape. And I can do any function here. For example, I can do the index function, which takes slices or maps, and then I say take this slice and give me the 0 item. And then I get Carson back because that's the 0 employee. But where the real power of these come in is using these as actual pipelines. And that means we have support for the pipe operator here. So I can do anything on the left. I can do a function. I can just do a bit of data. I can say, in this case, get the number of employees and pipe that to the next bit of this pipeline. And what happens is everything to the left of the pipe gets evaluated, and the result of that gets added to the end of the next thing in the pipeline. So in this case, I'm going to say printf, argument 0 is some formatting, argument 1 is this string of number of employees, and then the last argument will implicitly be whatever was to the left of the pipe. So if I run this, you can see that, yep, I printed number of employees, and I did some leading zeros with my string formatting, and said, okay, here we go, I'm going to pipe some results into you. And this can, used effectively, can really make for highly readable templates. Sometimes you use parens, and parens are fully supported inside pipelines, but sometimes using pipes is a lot cleaner. And I'll kind of show you some examples as we go of when I think you should use each. But just printing things isn't really all we want out of templates. We want them to encapsulate logic as well. So I've got my previous data, but notice now my company's empty. And here's an example of some logic in a template where I'm saying, hey, if company, print that company, otherwise print no company. And the same thing, if employees, print them, otherwise no. And if I run this, you'll see that we get what this kind of reads as. There was no company, and so it printed no company. But what I really want you to notice here is that this is simple. This is a very simple operation here. And the if conditions in Go templates operate differently than normal Go code. They're actually falsy, meaning that whatever the result of the pipeline to the right here is, and yes, I said pipeline, and I'll show you that in a second, the end result of that is evaluated in a falsy way. Not like Go. You don't have to actually say, hey, if company is equal to empty string, or if length of employees greater than 0. You can utilize this falsy behavior to coerce Booleans out of things that aren't Booleans. This is more like a scripting language, right? Where you don't have to be very, very explicit. You can let it kind of guess. And so empty string is going to be false. An empty map or slice is going to be false. Nil maps and slices are going to be false. Of course, Booleans will be false. It's sort of like you would think a scripting language behave. And this is very, very different from normal Go. And like I said, you can use pipelines in your conditions. So they don't have to be simple. In this case, I'm going to always print the company name, but I'm going to say, hey, if company is equal to weave, I'm going to print is great. Otherwise, if the number of employees is greater than 2, I want to print lots of employees. And this showcases when I think sometimes using the pipes can be more readable. This is very natural to me if company is equal weave. Whereas I think the greater than argument makes more sense to use parens as a replacement. And these parens will get evaluated first. And then the whole if condition, again, in a falsy way, will get evaluated. So if I run this, you can see that, yep, that's companies Go for Inc. has lots of employees. So next, let's talk about white space. So all of this is great. All of the logic that we've seen before is fine. But I want to put my logic on its own lines in my templates, right? So it would be nice if I could kind of separate the if conditions on their own line instead of making them run on like we've done before. And if I run this, you'll see that it works, but all of my places that had brackets didn't quite get removed. I have these empty lines, and that's not ideal. And this is extra white space that I want to deal with. And there's a way to keep this readability of our template language without getting those extra new lines. First of all, why are those new lines there? I told you everything between the braces gets removed, but if we kind of visualize the new lines in that template, they're outside the braces, right? They're separate from the braces. We've got these new line characters. And so that's why even though this gets wiped out, the new lines stay around and we've got those empty lines. So this is how some people handle that. They say, hey, well, if company, then print company, and if there are a number of employees, then print that. And you can see that they're handling these new lines by kind of just doing run-ons, and it's not great. It does result in the output that we wanted, where we had our logic without getting extra white space, but it really has made it hard to understand what this template is doing. So instead what we want to do is utilize chomping, or this kind of white space removal syntax that's available to us in the template language. So if you put a minus on either side of these double curly braces, it's going to eat all of the white space in the direction of that minus. So in this example, I put one here. It means it's going to go back and eat this new line that's available. Same thing here. It's going to chomp all of this white space, and what we get when we run this is the output that we want, but look how much more readable this is than that sort of run-on syntax. Chomping can really help you make nice, readable, usable templates without and still get the output that you want. But be careful. Chomping doesn't just remove new lines. It actually eats all white space in the direction that it's at. So if instead of putting it to the left, I put it to the right here, yes, it's going to eat that new line for me. But in this report, it's also going to eat these two leading spaces that I wanted to keep, that they're part of the report. So if I run this, you can see that, yeah, it got rid of that new line, which is there, but it also got rid of those leading spaces. So I didn't quite get the report that I wanted. So typically, people use the left chomp, and you can almost always think of that left chomp as a get rid of this line syntax. Although that's not technically what it is, it's eating white space in that direction. And the reason I say don't you can't always assume that this means get rid of the line. In the first line scenario, this doesn't work like you expect. If you just think, okay, minus to the left is delete that line, let's run this and see what happens. That top line is there, and that's because minus to the left doesn't really mean get rid of that line. It says eat all white space to that direction, but the white space is here. So you can't 100% think of it that way, especially in the new line, in the first line scenario. So if you needed to solve this exact example, you kind of have to go to a couple different things. You can fix it with a empty string with a chomp, meaning don't put anything here, but I do want you to chomp this to the left, and that's maybe a little better. Or in this first line example, sometimes you have no choice but to do the run on. That's just to be aware that both of these will print out what you expect without chomping extra white space. I don't love either of these, but be aware that gotcha is there. Most of the time, you can think of that left chomp as get rid of that line, but not always. Next, let's talk about comments, because as our templates get longer and more complex, we want to start giving information to the person reading the template to say what we're trying to do here. And they're pretty easy to use and understand. Templates in comments in Go templates are started with the same syntax as what you would do in Go itself. We have a double curly brace. You can do it with chomping or without. And then you do /star to start a comment. Put your comment text in there and // and then the ending braces to end it. And if I run this, this works. You can see that this top one got rid of that white space. The bottom one didn't. One thing I do want to point out, though, even though we're using a /star / syntax, which in normal Go is a sort of multi-line comment syntax, comments in Go templates cannot be multiple lines. In fact, nothing in Go templates can span multiple lines. None of the replacers. So if you do a double curly brace, that same line has to have the end. So I kind of wish they hadn't picked /star and // as the comment syntax, because it makes you think you can do a run on, and you absolutely can't. It has to all be on one line. But you can do comments all you want, just don't let the syntax fool you. Next, let's talk about variables. We need variables all over the place, and templates are no exception, because without them, you do a lot of duplicated and brittle work. So what I've got here at the bottom is a kind of more long-form company report where I print the name of the company and how many employees they have. And then this whole block here is essentially saying, hey, if they have one employee, then you do this. If you have two, then this is the message. If you have three or more, there's this other message. So all this is sort of just conditional message printing inside my template, which is not unusual. If I run this, it works, and we can say, well, Weave has 3 employees, and so we have the little message of 3 is company, safe and cheery. But I don't want to keep doing all of these length employees over and over and over again. There's a lot of them in this code, and it's very hard to read. So maybe to no one's surprise, we can use templates, or use variables inside Go templates. So I'm going to chomp away this line so I can get a nice clean output, and I'm going to use the : operator to create a variable. Now, interestingly, everything to the right of that : is a pipeline. It's not just a simple argument. It can be a full, long pipeline. Pipelines are everywhere in the language. In this case, I'm just doing a simple one saying, hey, get the length of employees and assign that to the variable $num. Now, in Go templates, you have to use $, and alphanumeric to do variables. They all have to start with $. They can't be plain. But outside of that, you kind of create them just like normal and name them whatever you want. So you can see how much this cleans up our template below. I just reuse num in all the places instead of redoing that calculation, which is both more work than needs to be done and a lot harder to read. I get the same output, but an arguably better template. But what if I go a little further? What if I say, well, okay, this whole extra block here is really just to determine each of these conditions is just determining a message. What if I wanted to set that message to a variable in each of those conditions and then just print it once at the bottom? That way I can keep all of my printing logic right there at the bottom. So I'm going to, in each of these, create a message variable and run this. And it breaks. And this one I expect. And that's because, just like in normal Go, we have scope in our templates. So if we create a variable inside of an if, it's only going to live for the duration of that block scope. But luckily, we can solve this. In Go templates, we have a : for creating a variable and an equals for reassigning. And I know this seems super boring and obvious because this is just how it works in normal Go. But this is actually a power feature of Go's template language. Not all template languages let you just do this. The idea of assigning a new variable versus just putting data into an existing one. If you've ever used some things like Jinja, this is incredibly hard. And you actually have to use things like maps to try to exfiltrate data using some special behaviors out of a conditional. So this kind of colon equals and equals stuff is super obvious and easy to use and really clean here. And if I run this, it does work. But this is actually a power feature of the language that not all of them support. So thanks Go for making something like this super easy to understand. Next, let's talk about dot. And it is canonically called dot. In all of the docs, they call it dot. And I like to call it the context of the template, meaning like what kind of data I'm operating on implicitly. Now, as we've seen by default, dot is representative of whatever got passed to the execute. So if we're passing an entire struct to execute, dot by default is going to represent that whole struct. And we've seen this already in the talk. But we can change dot. We can change our context both explicitly and it does change implicitly in some cases. And I think not understanding when dot changes is one of the big things that gives templates a bad rap, even though it's really a feature. So let's talk about how we change dot. We can change it explicitly using the with function, which is built into the template language. With is two things. It's a conditional and it's a context changer. So it operates just like if in a falsy way. So if whatever is to the right of with, then there's a whole pipeline optional there. So just like conditions and prints, you can do not just a normal variable, but you can do a whole pipeline. And the result of the last section of that pipeline gets sent to with. With looks at it and says, is this true in a falsy way? If it is, I'm going to execute the data in my block. And I'm going to set dot equal to the result of that pipeline. In this case, it's very simple. The pipeline is just the data company. But we're going to say, hey, if company's not empty, then run this block, and dot's going to be the value of company. So you can see, yep, dot at the top of my template was the whole struct, but inside that with block, because that's not an empty string, it got evaluated, and it was set to the string weave. Now this begs the question, how do I get data out of dot now that dot has changed? I can't just do dot employees to get my employee list inside this block anymore. If I'm in here, dot has changed. And this is where I think people get bit, but luckily there's ways to kind of save and break out of these blocks and get higher up data. We can do that in two ways. We can either use variables before our blocks to sort of preserve our data. So in this case, I'm saying, hey, $data equals to everything that dot is, which we know is that whole struct. And so I have my normal with company here, but when I need to get higher up data, I can use that variable. I can even index that variable just like I would have dot in the previous examples. Or if I don't want to use a variable and I just need to access the top data that was passed to my template, the $sign variable always exists and it is always set to whatever dot was to start the template. So I can just use $sign to print root, or I can use $sign dot employees to get employees. If I run this, you can see both of those work. Even though my default context dot now means weave, in that block I can still get things from higher up the chain, from outside that context change, either with variables explicitly or implicit, or with the $sign variable that's free for us. Next, let's talk about loops. So looping in our templates, there's just the range operator, just like in normal Go. Range always changes dot. It always changes your context. And I think this is one of the things that really bites people. It's actually a feature and allows you to write very clean and simple templates. But if you don't know what's going to happen, or you think you can keep it from happening, you're going to have a bad time. And I'll show you that in a second. One thing I want to talk about range before we get into it is that inside, even though it's the same keyword as regular Go, inside of templates, just like our if, it behaves a little differently. In a single value context, and I'll show you what I mean by that, but in a single value context, iterating over maps, you get the value, not the key, and iterating over slices, you get the item, not the index. What do I mean? Let's look at normal Go first to talk about what we already understand about range. So if in normal Go I range over a map and I print each, I'm getting just one thing off that range and I'm printing it, we're going to get the keys. If I range over a slice and I just get one thing and print it, we're going to get the element, or the index number. So if I print this, you can see, yep, I got devx because that was the key, and I got 0, 1, 2, 3, 4, or sorry, 0, 1, 2, 3. because that's how range works in normal Go, in a single value context, where I just get one thing off of that. In templates, it's flopped. So I'm going to range over a pipeline. Again, pipelines are everywhere. I'm just doing a simple one here, but this could be a whole series of operations, and the end thing gets passed to range. So I'm going to range over the team descriptions map, and dot is always, always, always going to be set to, for a map, the value of every element as it ranges. And if I do it same thing for a slice, and I range over just the slice, dot is going to get set to the element for each thing, not the index. And if I run this, you'll see, yep, instead of devx, I got amazing, and instead of numbers, I got names of people. And this kind of makes sense, because if you look here, this is what we want to do in template rendering. We really are, if we're iterating over a slice, we almost never care about the index. We're iterating over things to print. And this allows you to make very nice, clean, simple templates by utilizing that dot context. Now, all the same things applied as before. If you needed to get things from higher up, you'd have to use variable breakouts or that free $sign variable to get data from higher up while you're in a range. But this is usually an ideal behavior if you know what's going to happen. Next, let's talk about variable assignment. You can use one or two variable assignments. This is what I call a single value context for the range. You say range, you give the name of a variable, colon equals, and a pipeline, again, that you want to iterate over. And then you can use that. So I can range and say, well, I want value to be $V to be set for every loop, and then I'm going to print it. Same thing with employees. What I want to point out is, even though I'm now using variable assignment, dot is still changed. And I'm going to illustrate that in the lower down code, where I range over with variable assignment, print the variable, and print dot. And if I run this, you see that, yep, my range here worked the same way with that variable assignment, but even though I grabbed a variable out and I used that variable assignment, dot was still whatever it's going to be for that range, whether it's the values or the elements. I can actually do, just like in Go, I can also range and get two variables from that range. I can say I want to get the key and the value from this map for each loop, and the index and the element for each value in this slice. And then notice this isn't flip-flopped here. This is normal Go, key value, item, and index and item. It's not flopped here, but I can get both of those out and then use them inside of my block. But even though I'm grabbing all of the possible values of that range, I'm doing a dual value context here, you might think, well, surely it's not going to change dot because I'm capturing both of those things, right? No. Range always, always changes dot. So let's run this, and you can see that, yep, I was able to get key and value and index and element, but dot, those variables were what I expected them to be, but dot is always, always changed to be whatever it's going to be, which, like I said, is the flip-flop of normal Go. So use range. And just if you're aware of this context change, it can help you make very clean templates. But if you're not, I think this is where one of those really bad reputations come from. But it's really not too hard to understand if you know what's going to happen. Now, technically, the range operator in templates will let you range over a channel. I couldn't leave here without at least mentioning it because I find it interesting. I don't know why it would be useful. Maybe in certain command line scenarios where you're getting events and you just want to render them in a certain way as you get them. And the reason it's interesting is that your template evaluation, your execute, won't complete until the range inside your template can close. So if I'm ranging over a channel, I need that channel to get closed before the execution can complete. So here I'm sending something in the background for every second to send a message hello. And then in 4 seconds, I'm going to close that channel so that my execution can complete. So if I run this, you can see that, yep, range absolutely will read off of a channel like it wouldn't Go. Again, I'm not exactly sure why you'd want this, but there's nothing saying you can't do it. So let's move on to some of the power users. That gives you the very, very base understanding of how to use templates, but I want to move on to some of the things that really make Go templates work for you and how you can really leverage them. Okay, so we know that we can use variables to sort of make things cleaner. And this did get a lot cleaner from where we started. And I'm going to run this again to show you that, it's the company report, information about the company, and then a message. And if we look close, this whole block here is sort of a get message block, right? We're saying, hey, based on the number of employees, I want you to give me a specific message. Wouldn't it be great if we could rip that out and put that into normal Go code? Or maybe even use existing code that knows how to get a message based on the number of employees. And luckily we can, thanks to func maps. Func maps are pretty easy to use. First you write your function. In this case, I'm writing a static get message function. It's going to take the number of employees and return a message. And this is way cleaner and easier to understand, and you don't need all those braces and conditions and stuff to basically write a very simple Go function. The great part about this is now testable, and I can write unit tests around it, and it's easy to read and swap out. And if I want to use this in a template, I need to create a func map. Now, a func map is just a map of name to empty interface, meaning anything. Functions in a func map can take as many things as they need to and return as many things as they need to, 0 or many on either end. So I'm going to call that function getMessage, and I'm going to use the getMessage func. These don't have to be the same, but very often they are. In order to use this func map in our templates, I have to actually use it in the template invocation. So I'm going to use my normal must to handle errors, create an empty template called variables. Crucially, I have to load my functions into my template before I parse things that are dependent on them. So always make sure you put your .funcs before the parse. Otherwise, the parse is going to fail because it's not going to have the functions that are necessary. So this is way cleaner, and let me show you what the template looks like now that we've written a helper function and injected it into the template to be used. Now I can take all of that code out, just use the getMessage template, and again, that's where that string in the map was, and give it the number of employees, and I'll get a message back. So if I run this, I get the same output as before, but look how much cleaner this is. The function that I'm calling is testable. It can be as complex or as simple as I need it to be. In fact, it can change under the hood without me changing the templates at all. So it's kind of swappable logic. And I could reuse this as many places as I need. I could even use it in pipelines. So func maps are really some of the best way to add power features into your language. In fact, there's a lot of func maps that we use, a lot of functions that we put into our func maps to do sort of like JSON rendering or YAML rendering or special formatting. Anything that you can do in Go code, you can do in a func map, and a lot of times that can make for kind of more modular and clean templates. You don't have to make all these by yourself, by the way. Specifically, I want to point out the Sprig package by Masterminds on GitHub. This is a Go template package that comes preloaded with a bunch, a whole ton of functions. There's string functions, there's data manipulation functions, all sorts of things that you might need in order to kind of have all these extra power features in your templates, because Go templates are pretty sparse by default. But with basically one import and a function call when you're building your template, you can just instantly load your template with a bunch of very useful methods. So I'll actually point out a few of those that I think are very useful as we go. But no, you don't have to write them yourself, although you can. Let's get to one of my first power moves, and I think this is just fantastic. It's a way to really use func maps to make great interfaces and great templates. So I've taken our company data from before and added a features map. This is a map of feature name to state. So I've got BetaDB set to true, new UI set to false, and everything else is unset, right? So a feature's on, a feature's off. So we can use the index built-in function to index a map and get an item. This has some failures. Primarily, index doesn't have enough information to tell me the difference between this being false. Remember, index if conditions are falsy. So if I get this back, I'm going to get false by default, and I don't know that it wasn't set. So in this sample template down here, I'm saying, okay, well, if the new UI feature is enabled, print enabled, otherwise disabled. Same thing with BetaDB and auto update. So if I run these, you can see that, well, according the Weave company status says that new UI is disabled, BetaDB is enabled, and auto update is disabled. And that's not exactly true. It might be very important to tell the difference between not set at all or explicitly turned off. Typically in defaulting scenarios, you need to tell the difference. So what if we could make this cleaner and more usable and more flexible? We can do that using func maps and closures. So let's say I have that data defined above, and remember, in that data is a feature map. So I've created that variable. I'm now going to create a feature function, and that function is going to take the name of the feature and return its state. And it is now closing. That data is defined above, and this function I'm making now gets to do a closure over that data and just build it into the function. So I don't need to pass features because it's kind of enclosed in the function when I create it. So now I can say, hey, well, if you get a certain feature by name and that value is found in the map and it's true, we can return it enabled. If it's false, we can return disabled. If we didn't find it in the map, I can return unset. Now I loaded in my func map like before, calling it feature and pointing it to feature. And look at what it does to our template. Now, instead of having to use index and pass the feature map every time and get that kind of not perfect behavior where we don't really know if it's enabled or disabled, I can get rid of all of that and just use this feature function that I've created. If I run this, you can see now it can tell me if it's disabled, enabled, or unset. So this is a way easier interface for our users to understand, and it's more flexible to boot. So I think you can do some amazing things in GoTemplates by kind of making closures, make functions that close over data, and it allows you to not pass things while still being more flexible. Next, let's talk about how we might reuse bits of code without having to necessarily create new functions and use func maps. If you only have access to, or you want to just do this all in templates themselves and make reusable code, we can do that. We do that by, in this example, I'm created an employee type that's just got a first, last, and a job. And then I've got my company, and employees is now a slice of employees. So say I want to do my company report, and I want to print the employees in a very specific way. I can do that by using the define keyword, give that subtemplate a name, and then inside that I just do normal template logic. It can be anything you want, conditions, all of that. Then when I loop over my employees, I can then say call the subtemplate called employee and give it this bit of data. And again, we're in a range, so inside this range, that's going to be one at a time the value of each of those slice members. And if I run this, you see that, yep, I was able to kind of define how my employee printing should work at one place and then just reuse it lower down. And I could reuse that subtemplate as much as I want over and over and over again. So this is one way that you can kind of lift logic and put it in one place and reuse it multiple places without writing func maps. But what if I wanted to go a little further? What if I wanted to have this subtemplate have some logic and say, well, I want you to do an employee report, but only for employees that have a certain job, for example. According to our template docs, they say you call template, the name, and then a pipeline. Remember, everything's pipelines. And if I try to do this here and hit run, you'll see that it doesn't even compile because you can't give more than one argument to a template invocation. But utilizing the tuple helper function, which we can either get from Sprig by default by loading it in, like I said, or by writing it ourselves, and this is the whole tuple implementation. It's trivial. We're taking any number of things and returning a slice of those things. So you can kind of just say, give me all the things, I'll condense them down into a slice and give them back. So it's very, very trivial whether you write it your own or use Sprig. Now look at what we can do. We can use tuple and parens inside this template invocation to say, well, I want you to give you the employee I'm working on and the job title I want to filter by. Then up here in my subtemplate, I can use the index function to say, well, take that tuple. Remember, it's both of these things now. And the 0 item is the employee, and item 1 is the job I want to filter on. So I'm going to set those to some variables. Now, of course, I can't just use dot anymore because dot is two things. So I do have to rewrite my conditions. But I can do it now. I can say, hey, if the job that you gave me is equal to the employee's job, print employee report. And notice I had to do all these $e's because dot has now changed to be two things. So I pretty much always have to use a variable. And that's not too bad because it allows you to make very, very flexible subtemplates that can take arguments. But I hate this. I hate using $e. And we know how templates work, and we can do better. We can use tuple and width to pass arguments to our subtemplates and then reset dot to be something else. So I'm doing the tuple just like before. I'm getting the job out of item 1 like before, but now I'm using width. I'm saying index the 0 thing, which in this case is going to be the employee, and as long as that's not nil, then I can do all my logic inside that width. And so I can say, hey, if $job is equal to the employee's job, and notice my $e is gone. Dot is reset. I've explicitly reset it with width. So now I can essentially go in and have a normal employee subtemplate that accepts arguments without having to rewrite the whole template. And this is especially useful if you've got a long form existing subtemplate and you're like, I love this subtemplate, but I wish I could just pass it a bit of logic or an argument or two. You can do this and not have to rewrite the whole thing with a bunch of $signs. So this is one of my favorite power user moves. So here's how we started with GoTemplates. We've got an emoji map, a map of names to emojis. We've got a scary thing string. In this case, we've got fire and heart, and syntax is the scary thing. We're doing our normal parsing. And this isn't too bad, but it's not great, right? We've got using index, emojis, fire to get the fire emoji. We're doing some unnecessarily complicated if logic, saying, hey, if not equals scary thing. Like, it's not ideal. further down here, we're quoting scary thing, but we're kind of quoting it with quotes outside of the braces, which means if scary thing has quotes internally, they won't get escaped properly, and that would break. So it's not a safe quote by any means. And we're doing another index here, and a lot of run-ons because we're not sure how to handle white space, so we do run-on blocks. If I run this, it does print, and it works. So it's not too bad. We're using Go templates here. But now let's go a little further. This is where we're at now. We write some helper functions, and these are nice and reusable and very powerful. In this case, I'm just using an emoji function that does a closure over the emoji's data, and I'm returning it if I find it. Otherwise, I'm returning question mark. So it's more advanced than the index. Remember, the index would just return the default thing, which would have been empty string. I want to return question mark, meaning I don't know. I've also written a quote function that is just a very, very simple wrapper around the sprintf quoter. So this is a very trivial function, again, to write. But look what all of this, plus a little more Go templates knowledge, does to the template below. We can say, hey, Go templates are emoji fire. Again, this will get it from the closure. But I could have this emoji function that I'm creating call out to Emojipedia. I could have it do all sorts of things beyond just the data closure. But even that, it makes this much cleaner interface. Then I'm using whitespace chomping to do nice, clean logic. And I'm using width to not have to do a bunch of if not equal empty string nonsense. So clean, concise. I can also use the inside that I know that dot is now scary thing, and I can pipe that into my quote function. So I can say, hey, take whatever dot is and quote it. And then again, reuse my emoji function here. And now it's the same output, look, but it's safer, more understandable, and more reusable than what we had before. So that's it. Thank you so much for watching. Hopefully this has given you an idea of what you can do with Go templates and the power that comes with them. And I really hope this has done a lot to give you ammunition against anybody that says Go templates are terrible, because not only are they not terrible, they're incredibly powerful, and in a lot of cases do things that other template languages just don't support in the same way. So again, my name is Carson Anderson. I'm a DevX engineer at Weave. You can find me on Twitter at Carson_ops. You can find me and this presentation and every other presentation I've ever given at github.com/carsonoid. I actually have more followers on GitHub than on Twitter, so I'm great if you want to just go follow me on GitHub and leave Twitter alone, because I think that's kind of a badge of honor at this point. Again, thank you so much for your time, and hopefully we'll be giving another talk soon.